Okay. Let's see. So we got today and tomorrow. I've got you for a full day. So tomorrow is a full day. Friday is your half day this week. I'm going to be out for golf on Friday. Did I have you doing anything on Friday? I didn't really have anything
You shouldn't because it's
going
senior
for
skip
Friday
day.
anyway.
Good,
So,
because I wasn't gonna do it anyway.
Great.
I'm not gonna come just because I don't want to be the only one in here.
that's perfect. So that's the plan for this week. So we're starting a new unit. It's going to be similar to what we just did with confidence intervals and hypothesis testing, except instead of doing for proportions, we're going to do means. So it's going to be similar, just there's going to be slight variations here and there. And so yeah, so what we're going to do today is, or actually this week, we're going to do confidence intervals, so today and tomorrow, and then after spring break, we'll do hypothesis testing. And then we've got like 3 units left, so this one and 2 more. And then that would take us to about early April, we're going to start reviewing for like a month. And because we all need it, you know. Who the heck knows what we were doing in September at this point, October. Getting that stuff in. But yeah, that's our plan. So we're going to do something today. There is an assignment from today's work, and then tomorrow is 2 sample stuff, but there's no assignment on that. So that assignment that I'm going to give you today is like due by the end of the week, I think, something like that. Okay, so I'm going to do this, the page with like the Oreo, the first one, but I'm going to skip over to like the important ideas first, okay? So go over to the back side, and then you can use that big blank space, because it's the 2-sided paper, so it's this one. Did you get this one? Yeah. Use the back side there. Use the big empty space if you want instead of the little box. So if you remember, not actually, here, the formula sheet says on the confidence intervals, it says something like this. Let's see, it says statistic plus or minus critical value times standard error. So that was confidence intervals. So that's what we did like right before hypothesis testing. And so, yeah, so let me do it this way. So what we did with proportions is we had our p hat, and then we did plus or minus our z-score, which comes from being like 95% confident, 90% confident, whatever. And then we did times the standard error formula, which the formula sheet says something like that. Maybe, let me just point to those on the formula sheet real quick. Let's see, so the formula right there, statistic plus or minus critical value standard error. The formula for standard error was right there on the back side, proportions standard error. So on the back side, there's another one. Okay, so we're going to do it for means. So now we're doing means instead of proportions. So we're going to do problems with means, averages. And so our formula for means is our sample mean is x bar plus or minus. And then the formula for standard error on your formula sheet, it says s of x equals s over the square root of n. So we're going to go over that. And then here's the first thing we're going to talk about today. Instead of a z, we're going to do this thing called a t for means. So we use t for means. You use a z for proportions. And when you came in, hopefully you picked up this paper table here. This is for you to keep. It's not, I didn't laminate them because it takes a while to laminate, and then you have to cut out So I just printed a bunch for y'all to keep, and if you lose them, I have more that I can print for you. And so we're going to go over how does the T table work, and what is it, and then we're going to do a problem. So on the formula chart, if we're at home or whatever, so like you're scrolling down, this is the Z chart, and it looks like this. If you keep going, there's a T chart at the bottom, and we're going to go through how to use the T. And then at the very back, it's chi-squared, which we'll talk about that later. But okay, we're going to use this T one. So what do you think about 120% zoom? Perfect. Wow. Okay, let's talk about the T. Where do I want to start here? So let me get a new page. What do I have written down for myself? So the T table is it's a normal distribution. It's just, it's actually just a little bit more spread out. And it works a little different. So let's go for this. So let's go like the T table notes here. So we use with means. So you're using it with means. For proportions, you use z-score, the Z table or whatever. Okay, so some notes. The way to use the table is, it's a mix of your confidence percentage and something called degrees of freedom. How free are you? What's your degree of freedom? 100%? No, it doesn't work like that. But degrees of freedom. So degrees of freedom, I'll just label it DF, is how do you get it? We're going to practice it. Degrees of freedom is your sample size minus 1. So it's not that hard to calculate what your degrees of freedom is. Whatever your sample size is, minus 1. Let's see, this might be worth it to discuss. So why is it n minus 1? It's because if I told you the average test score on the last test was an 80, and I gave you everybody's score except one, you could calculate that one person's score, right? You would do like multiply by the sample. You could do it. If I gave you the sample mean and everyone's score but one, you could get it. So that's why we could take away 1 from our total, whatever. So this is how we're going to get it. And then you get it from being like 95%, 90%, ... Let's see. Okay. So yeah, let's do our problem. So I wanted to start with this, just you doing the table first. Then we're going to try and do a problem together. Okay, so use table B to find the critical value T star that you would use for this confidence interval and do it there. Okay, so what if we're trying to do a 98% confidence interval on a sample of 26 observations? Okay, so first things first, and you'll see why once we look at the table, is we need to know our degrees of freedom. So I had a sample size of 26 minus 1, so my degrees of freedom is 25. So let me go to your table that you have, go to that chart, and let me see. Okay, so I'm on my T table, and there's two things here. You can see DF, so all of these numbers here on this left side are your degrees of freedom. So if you have a degrees of freedom of 1, this is your row. So let's see, our degrees of freedom, if I use our table, wasn't it 25? Uh-oh, the smart board's off a little bit. 25. Even if the smart board can't get it. Okay, actually I needed to scroll down a little bit. So at the very bottom is your confidence level. So at the very bottom down here is confidence level. So if you want to be 95% confident, you use this column. If you want to be 99.9% confident, you go over here. These numbers at the very top, we're going to use with hypothesis testing. So just go ahead and don't worry about those right now. We'll use those later. So for today, we're going to use confidence level down here and degrees of freedom. So what was our problem? We were 98% confident with a 25 degrees of freedom. So then, where do those meet? 2.485 would be your T-star, would be your critical value. So if I was doing the problem, see if I can actually click on it. I did. Okay, so if I was going back, did I erase it? I didn't. So if I was doing my thing, that would be like the T that I plugged in right here, and then I plug in this other information that's given to me that I find. So that's how I find my T. Okay, so I use the table. So let's try B. Try B on your own. Then maybe I'll come up with another example. So 99% confident, 85 observations.
Are we just looking for the table right now?
Yeah, we're just practicing looking at this table. Literally just want you to get comfortable with the different table. Alright. So this one's kind of weird. It's a degrees of freedom of 84 and a 99% confidence. Alright, so this one is strange. So this table always has limitations. Like the Z table has its own limitations. So if I look at this and you go down to your degrees of freedom, it starts to it goes to 30, 40, 50, 60, 80, 100, 1000, infinity. So it really starts to go from there. What you want to do, if your degrees of freedom, so if degrees of freedom not listed, what they say is round down to nearest degrees of freedom. So like in this case, I'm going to go down, and the farthest one down was 80.
What's there an infinity then?
That would be, I guess,
Like, if they don't say.
like that's just like a hypothetical, like this is like a perfect 1.96. This is actually, so 1.96 is like a perfect Z-score, 95%. I don't know if you, and then 1.645 is a perfect Z-score. So this would be like if it was like a hypothetical, like infinite amount of samples you could do. You're not going to use it, so don't worry about the infinity. Don't worry about it. Okay, so like if I had a degrees of freedom of 79, I would have to go all the way down to 60. Like that's just like the limitations of the table. So always round down. Don't always go up. The reason, maybe I'm not going to go into that. Sometimes I think too much information is bad. So let's see. 80. What was my confidence? 99. So then I always get scared I didn't go to the right thing, but I did get that before. 2.639. So for some reason when I'm looking at it, I always have to like close one eye, and like then I'm like, I don't know. I saw a lady, she was like using her paper. That's pretty nice. Never thought about that. Limited. Okay. How about, let me just make up an example so that we get another one. What if we did like a 95% confidence interval at like, let's go 45 sample size. Okay. So I'll grab the paper, we'll look at it too. 95% confidence. All we're doing is just getting the T, 95% confidence at, so that would be degrees of freedom of 44. And the table, I would actually have to use degrees of freedom of 40 on the table, which I think you get 2.021, hopefully. Okay, so it's a little different than the Z table, but once you understand all the things on it, it's really not that crazy. If you just get where the columns and rows mean, you'll be good. Okay, so what I want to do is I actually just want to jump into a problem and just do some problems with you and try it out. So we're going to do the other note page. And we're going to get some class data here, and then we're going to do a problem on the back. So I'm going to do a couple with you, and then work out. Alright, so what I want is get a piece of paper that has some empty space, or write it on the side. And what we're going to do is I'm going to set a timer, and you're going to write as many states in 1 minute as you can. And I'm okay if you want to abbreviate. I'm okay with that. So if you want to say TX, NY, what, I'm giving you too many. Now I'm giving you the answers. Okay, so what I want you to do, so find the paper, I'm going to set my timer, and we're going to see how many states can you do in 1 minute. All right, everyone ready?
Yeah.
Got it? Okay, ready, go. Uh, 10 seconds. Pencils down. Stop. I always wanted to say that. I remember taking, it was called the tax test back in the day. That's like the star. And they would always do it at the very end. Pencils down. It's like, calm down, we've been doing it.
Yeah, honestly, like, when we
So-
took the SAT last week, I think his name was Coach Jackson, is that?
Yeah.
On the basketball coach, he was the proctor, and every time he would talk, it made me like jump because he was so loud, like.
Like
Deep voice, yeah.
it's
Okay.
really, really
I know, that's what I was.
Count how many you did.
So I just
Get your number, count how many you got. And I'm gonna make a little dot chart for us here. Let me see.
I think that a minute, I'm not all the states, I just.
Sure you do. Sure.
I forgot the beginning of the song. I was like,
Yeah.
Alabama.
Alright, how many did you get? 18? Okay. Alright, so you can do this dot table if you want. So that was an 18, so yeah, that's close enough.
16.
16, okay. Alyssa?
12.
12, okay. Let's see, I'm gonna go about there, it's good enough. Lydia?
26.
Wow, you think you're so good, don't you? Emma? 12? Okay. Lee?
24.
24, not as good. Holly?
Sorry, I can't spell.
Oh, 21. Okay, here.
14.
14. Okay.
16.
What? I think this was a 16, wasn't it?
18.
I think that was an 18.
One.
I put the K.
18.
Okay. All right. Nice. And then the thing is, it's kind of hard with us with like not a lot of dots, but there's our dot plot. There we go. Okay, so I think that's pretty, if I remember from past years, it's pretty accurate.
Are you gonna call us liars?
Well, no, not
I don't
liars.
know the
Just
abbreviation.
I should have saved year to year, and then I could say
Yeah.
like y'all aren't as good as, or y'all exceeded them. Okay, I just can't remember. Okay, 26 is pretty good. Maybe I'll keep this and see if second period.
Okay.
Before I forget, I don't need to erase this.
Well, it's on your video now, so.
All right, that's true. Okay, so what we're gonna do is, what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we did a sample size of 11. And what we need to get is we need to get our, what those are is that's your sample mean, and this one is your sample standard deviation. So X bar, SX. That means sample mean, sample standard deviation.
Wait, so X bar is sample mean and SX is standard.
Sample standard deviation,
Right.
yep. Yep.
Why did they have to change this symbol?
So, because like if I'm talking about the population, I'm gonna use this signal, this thing.
I mean
with-
for standard deviation, or is that just?
Cause then this is population standard deviation, that's to say this is sample. So this is population, sample. Okay, so how do we do that? We just have a bunch of data. What we're gonna do is grab our calculators, and we're gonna put it into a list. So you need to know how to do this. We're gonna do it on the back side too. Sometimes this stuff is given to you, but sometimes on means, they want you to calculate it. So you need to know how to do it in the calculator. So yeah, if you don't have one, get one. So what I'm gonna do is I'm gonna make a new document, and I'm gonna make a list and spreadsheet. And if you're the online people, like the TI-84s is like second stat, I think, or second something, I forget. But you can also make a list there. Okay, and then on the Inspire, it's kind of dumb. You need to name these things. So let's name it whatever. It doesn't matter. Just give it some sort of name. So I put H, like it. Just put something up top. Otherwise, it won't see your list. So what were our numbers? Were what? Let's see, we had 12, 12. So I'm gonna go 12. Enter. You don't have to do it like least to greatest or anything, but that's what I'll do. So 12. Then we had a 14. We have a couple 16s.
It was 12, 12, 14.
Yeah. Yep. 12, 12, 14, 16, 16. Then we had 3 18s. I'm gonna go 18, 18. And then I think that was a 21. 21, 24, 26. So 21, 24, 26. And it came out to 11, so let's get the sample size of 11. Okay, so I put my data in. It doesn't have to be in order. Like you can, but it doesn't need to be. Alright, so then, at least on the Inspires, what you do is you're gonna make a new page. So I'm gonna go to Control and then Doc. So Control Doc. And I'm gonna add a calculator. So it's just like a blank page. I'm gonna click Menu. Stat calculation.
Oh, I pushed off.
That's okay. It should still be saved. So you go menu, stat, calculations, and then you're going to do one variable statistics. So we've used this before in the past. It gets you like your mean. Why can't it work?
I'm sorry, was it data and spreadsheet? Or what?
Your first one?
No, the second page, what was it?
Your second page was just a calculator, add calculator. So it's like number 1. Okay, so then on your one variable stats, so you go menu stat, statistics, calculation. Make sure that your list is whatever you named it. So mine was H, because I just typed a random thing. So
The
make sure it says
frequency
that.
list or the category list?
The X1 list.
Alright.
And then frequency, category, everything else just stays the same. Because like we just have one list. And I'm gonna click OK. And it gives you, if you scroll up, it gives you your X bar, your standard deviation, it gives you your N, and then we used it for our box plots early on in the year with the min, Q1, median, Q3, max. So it says that too. Okay, so what I see on it is we have an X bar of 17, maybe I'll go 2 decimals, 17.73. And a standard sample standard deviation, 4.52. If I'm going 2 decimals again. So help me remember those numbers. 17.73, 4.52. So I already forgot them. 17.73, 4.52. Wow, genius. Photographic memory. I wish. Okay, so that's our sample. Like our small sample had an average of 17. So, compare yourselves justly from there if you're above or below average. And either boast in pride or sulk. And then you got a standard deviation 4. So that's our little table that we've got. So what we're gonna do is, I didn't really do this is not really a random sample of students, because y'all are specifically like my AP Stat students. So I can't really get a ton of information from y'all. But what we're gonna do is we're gonna make a 95% confidence interval on what is the true average number of states that Mr. Hamilton's stat kids can do in 1 minute. And I'm going to get a confidence interval for that. So we're going to use this information to do a 95% confidence. Okay, so let me try this out. So number 3. I'm not on your notes page. It has a bunch of like outline portion. You can. I'll be going through that, just not quite on the same page. Okay, so what we're looking for. So maybe I should say that first, like the parameter. So this is the parameter. A parameter is what's the thing we're wanting to know about our population. So it is like. What did I say? It would be the mean, which is the actual number of states, and maybe I'll just generalize it to AP Stat students. So the actual number of states AP Stat students can write in 1 minute. So I can't really generalize this to all students because y'all are not all students. Y'all are just an example of AP Stat students. I didn't really do a true random sample. Okay, so that's my parameter. What I'm going to do is let's do our conditions. All right, what were our 3 conditions before? What was the first one?
If it's random.
Yeah, first one, did we do a random sample? And so on this one, is like, y'all could be, I don't know. This is not a great example of doing a good random sample because y'all are my students. This would be a very convenient sample for me to do. So what we're gonna do is we're just gonna kind of bypass that on this example here. What that means is, let me just write this out. So this is really not really, and so we can only generalize to AP Stat students. Like, I really can't say about all students, because you aren't a good example of all students. You're just a good example of AP students. And not even that, just AP Stat students at Bryan High. So it's not a very good, whatever. All right, what was the second one? What was the second condition? Yeah, we needed to be, is our sample size less than 10% of the population? And so, yes, like, well, this is kind of a bad example again. Like, our population is really just, we're going to try and generalize to all AP Stat students. So we're going to say that, like, sure, you are less than 10% of all AP Stat students. So that's a pretty big stretch. Because the AP Stat students at Rudder are different than Consol, different than Conroe Heights. Like, so I didn't really do a good sample of them either. But whatever. This is, we should keep going through it. And then number 3 was our distribution, can we have a normal sampling distribution, normal distribution? Alright, and so for the P, it was n times P, n times 1 minus P. We don't have a P anymore. We're not doing percentages. So on means, there's 3 things you can check off. So like the first one is the population normal? Which we have no idea if our population is normal. I don't know the true number here. The second one is your sample size bigger than 30, greater than or equal to 30? Which we kind of failed at this one too. But then there's a very last thing that can check off to make it okay. And the last one is your sample without skew? So was our dot plot pretty good? Our dot plot, that's a pretty, like, I mean, if we got more, it might stack up. But for right now, I mean, that's like not bad. It's kind of might be a little skewed, but we're gonna go against it. So what we're gonna say is this last one is your sample data not skewed? And so that's where we actually get to pass the test here with a check. Yes, we win. Okay, so we didn't really do a random sample, but yeah, so we that just means if you didn't do a random sample, I can really only say it about a few people, not everybody. Okay, so let's actually do our problem now, or like do the thing with it. So let me write the formula, which is what I wrote at the beginning of the day, which is you do your statistic, and then you plus and minus the margin of error. And the margin of error is calculated by the t-value times, and then how about I just write this? How about I'll do standard error, and then we'll look at the formula chart. So the formula chart, if you look at it, it says this on the means for one population. It says S over square root of n. Alright, go ahead and fill this in. So this was it 17.73? Is that right? Okay, plus and minus. Let's get our t. So what's our t value?
Would be 10 and then
So yeah, the degrees of freedom. Let me go to our table. So we got a sample size of 11. Sample size of 11, which means we're going to use a degrees of freedom of 10. And then we're doing 95% confident. So 2.228 is our t value. 2.228. Times, maybe I'll put this over here. So S was what, 4 something?
yeah,
4.5? 2, okay, over the square root of 11. Alright, so what I'm going to do is I'm going to calculate this, put it down here, and then plus and minus it from our number. So 2.228 times 4.52 square root. 3, so let's see, we're doing 2 decimals because that's what I chose for the problem. So 3.036, that'd be 3.04 would be your margin of error. So then you do 17.73 plus 17.73 minus. Okay, so I got 14.69 and 20.77. Okay, so before we before I write it out, if I wanted to make this smaller, like a closer interval, I need to increase my sample size to decrease the spread. The spread gets smaller when you increase your sample size. Just so you know. So that 14 number, what I could say is, so I could say we are 95% confident that, and then I'm going to say my parameter, which was something about the actual number of states AP Stat students could name in 1 minute. So that's what I'm going to say. We are 95% confident that the actual number of states AP Stat students can write in 1 minute is between, so then I actually get to write my thing. So before I write, so you get your percent confidence, then you just write out in words, and then you say your interval. So the actual number is between, what was 14 point something and 20 point something? What was it? Somebody help?
14.69 and 20.77.
77? Okay. So somewhere between there is the actual number that y'all could do in 1 minute without any practice. I bet y'all could do better the second time, because now you're practicing it. But, first time, writing in 1 minute, the number of states, is somewhere between there for like AP Stat students. That's kind of the problem. Is we think anywhere within that interval is like the true number, at least for this class. And we're gonna try and push it to say all AP Stat students, but that's kind of a stretch. Okay, so we're 95% confident that it's somewhere in there. I'll kind of go back. So your bones of it is still the same. It's just we've got means instead of proportions, the T-star, and then this is still just the formula sheet, like looking on the formulas and plugging it in and getting the information. So it's similar in what we're doing, just a slight variation. Okay, so let's try another one. Let me do the backside. And let's actually let's look at B. So the check your understanding, B. We're just gonna do another one. So what we've got here is we're wanting to know how many pounds of trash like a household has per week. And so this is what we're wanting to know. Let me check something real quick. So yeah, okay. So what we got is this is a random sample of 15 households, and this is their data for the week, somewhere within here. So we want to know what is the 95% confidence interval for the households in this community. So this is like our parameter right here. This right here, the weight of trash in the community per household. Okay. So first thing is it doesn't give us the sample mean and sample standard deviation. So what we need to do is we need to calculate the sample mean, sample standard deviation. And I know it seems repetitive and little, but they'll ask you to do this, and it happens a lot where you just type it in wrong and like miss out. So I want y'all to type this in, get this in your calculator, and get me the mean and standard deviation. See if you can get it correct. those in, the tedious task of getting all your decimals correctly, naming it, and hopefully I did it right. 68.85, I think. Anyone else verify that? Okay, we're all wrong together if that's the case. And then 35.78 should be your SX, sample standard deviation. So identifying them on the calculator, making sure we can do it, get our numbers, so that's what we got. Okay, so let's do our confidence interval and try it out from there. So I'm going to be a good stat student and I'm going to do my conditions because I am on top of it. I do not skip out. Okay, so did we do our random sample, and it said they did a random sample of 15. So is 15 less than 10% of like the households in this community? And we're just gonna have to say that like, unless it's a super small town, like there probably is more than 150 houses. That's pretty realistic. And then the last one, is it normal? And so, is it normal? And so we have no clue about the population. Our sample size is less than 30, so we're kind of screwed on that one. And so is our data, we didn't do a dot plot for this, but is there like no real strong skew or outliers? And so if you actually do it, like made a dot plot of it, it's really not that bad of a, like there's a few high, there's a few low together, and there's a few in the middle. So it's actually a pretty good dot plot. There's no strong, like really obvious outliers or skew. So that's what I'm gonna say. I'm gonna say like no strong skew or anything like that. Or like you could say outlier / outlier. The dot plot kind of shows them they're relatively okay. It's not like perfect. That's what I got. Okay. So I'm doing it 95%. So I'm going to go ahead and write my formula. So it's sample mean plus and minus T times standard error. And so the formula on the back says S over square root N. Alright, so I got 68.85 plus or minus, S is 35.78 over the square root of 15, and then I just need to find my T. So sample size of 15 would mean I'm going to use a degrees of freedom of 14. So 15 minus 1. And then it's 95% again. So 2.145. So 2.145 is what I'm going to use. Okay. I'm going to get my calculator. And I'm going to do 2.145 times 35.78 over square root of 15. Enter. I got 19.816. So I'm just going to keep it all in the same rounding. And so we've done 2, so I'm going to do 2 again. So 8.2. So 68.85 plus and minus that is going to be the number. Can't read my own writing, but I believe that comes out to something like 49.03 to 0.66. And so then all I'm gonna do is just say how confident I am, put the parameter that this interval is this. So I'm gonna say I am 95% confident that, and then the question is the weight of trash for all households in the community. So I'm 95% confident that the mean weight, I'm just rewriting the question, the mean weight of trash for all households in the community, and then I'm just gonna say my interval is between 49 to 88.66. So somewhere in the 49 to 88 pounds interval is where we're gonna be. So 95% confident, somewhere within there it's gonna be. So super similar to proportions, just using different formulas, just slight variation. So if you had struggled with the proportions or got that, then this is where it's like, okay, like it's gonna hit you again, so get some help. And there's some new formulas like using the T and all that, but for the most part it works just about the same. So what I want is, I've got an assignment with 3 questions, and we're gonna work on this, and you've got, I guess I'm giving you the week to do it, but if you're gonna turn it in person, you might wanna turn it in tomorrow, I guess, at some point. Tomorrow we're gonna do 2 sample confidence intervals, and there'll be plenty of time to work on some stuff as well. So